All right. Hello, everyone. Back in this thing, trying to do more DSA questions. Personally, trying to do some two pointers. I want to do breath first search and depth first search, but these two pointers and sliding array, sliding windows, I'm sorry, I'm still not able to just look at a question and be able to solve it. Like the ones that you do see that I quote unquote solved, I looked up solutions of how to solve it, and I feel like I need to just keep coming back to these types of I need to keep coming back to these types of questions until I figure it out. Like I at least understand how to do two pointers because you have one pointer that might be like might be a left pointer, a right pointer. Maybe there'll be three pointers or four pointers, and then you will use like for loops or while loops to move them and then you'll check certain conditions or certain conditions are made. There's a lot of connections between, there's a lot of like similarity between um, sliding window, sliding window and two pointers. But let me stop talking and just start getting into permutation. So here's the plan. The plan is I'm going to try to do this for 20 minutes, 15 or 20 minutes. If I can't figure it out in 15 or 20 minutes, I'm just going to look up the solution. Great. So let me read the question. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, array 1, 2, 3. The following are all permutations of array 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1. So there's different types of yeah, there are different type of orders within this 1, 2, 3. The next permutation of an array of integers is the next lexo lexico lexo lexicographically lexicographically. I don't think I'm saying this correctly. Lexicographically. Let me see this. There's lexicographically. And the next lexicographically great permutation of its integer. More formally, if all permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible order, sorted in ascending order. I just read all this and I don't actually understand what I'm reading. Maybe I just look at the example. For example, the next permutation of array 1, 2, 3 is 1, 3, 2. Similarly, the next permutation of array 2, 3, 1 is 3, 1, 2. While the next permutation of array 3, 2, 1 is 1, 2, 3 because 3, 2, 1 does not have a lexicographical larger rearrangement. Given an array of integers nums, find the next permutation of nums. The replacement must be in place and use constant extra memory. Use only constant extra memory. So I know I definitely need to read this again, but the constraints is for the nums length, it's going to be less than 100. It's going to be 100 or less, or 1 or greater. And in terms of the number of or at a length, the numbers within the array is going to be either 0 to 100. This lexicographically thing is really tripping me up here. The next permutation of array is the next lexicographically greater permutation of its integer. More firmly, if all permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of the array is the permutation that follows it in the sorted order. If such arrangement is not possible, the array must be rearranged as the lowest possible order, sorted in the ascending order. I'm honestly don't even know what I'm reading right now. I'm not even understanding what's happening. So 3, 2, 1, 1, 2, 3. Lexicographically? What is a lexicographical order? Let me first just look into this. Man, it'd be crazy if I get this as an interview question. The lexicographical order, also known as dictionary or alphabetical order, is a method of sorting sequences like words or numbers by comparing the elements from left to right. The elements are ordered based on the smallest differing value, with the shortest sequences generally appearing first. Sequences are evaluated starting at the position, sort number is determined the moment two corresponding elements. Computer versus human sorting. While similar to standard dictionary rules, computers strictly rely on characters encoding. Because of this, uppercase characters typically sort before lowercase ones. I'm still a little bit, not even a little bit, a lot of bit confused here. Following are all permutations. 1, 2, 3, 1, 3, 2, 2, 1, 3. Okay. I'm still trying to figure out how they come up with the output. Is this supposed so 132, hmm, 115, 151, 321. Is this supposed to get to the like the highest level? And if it can't get to the highest level, it goes to the lowest level? Is that what's happening? I think that's what it said. Wait, let me read this. The next permutation of array integers is next lexicographically greater permutation of its integer. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows in the sorted manner. If such arrangement is not possible, the array must be rearranged as the lowest possible order. So I think what they're saying, yeah, I think what they're pretty much saying is based on the combination of numbers, what would be the next increment of that number, or the next order of that number? Because, and if this is if the starting number is the highest number that it can be, then you just got to get the lowest number. Okay, I think that's what they're suggesting. It took me about almost 8 minutes just to figure this out. Okay. I'm probably never gonna solve this because I don't even know how it start, to be honest. Um, because looking at the array, there could be 100 different possibilities. So 100 times 100 is what? Um, Let me see here. 100 times 100. What is 100 times 100? Is it like 1,000? Right? It's 10,000. Okay. So there might be a situation where I get 100 different numbers and there's 10,000 possibilities of what could be the next array. I'm thinking the first thing I would think is how would you be able to create all the different permutations, right? And then sort them from beginning to end. That's the first problem, which I don't know what to do in terms of that. How would you be able to sort them? I mean, be able to come up with all the different permutations. So if there was 100 different items within the array or numbers within this array, how would I be able to sort them very quickly? I mean, not sort them, get all the different permutations, possibly put them in an array, then find the current permutation and do like I don't know, with PHP, does it explode? I think implode and then turn it into a number. and then try to find the array key that's within that number. And then if that's the number, then find the next array key. But if that array key is at the last, then just go to the first. The permutation part sounds the hardest thing to do. Like, how would I get all the different permutations? Because mm, I got to think out loud for this one. How would I get all the permutations of this array? Mm, I'm trying to think. How would I get all? Mm, I mean, I could do a for. I could do some type of loop. I could do a loop and then try to rearrange the numbers in some type of fashion. But I don't know what's the best way to rearrange these like numbers. Boom, 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 boom. Okay, so I think there needs to be an array that already has these numbers, right? I maybe, hmm, hmm. I think first you need to know how many items there are, right? And based on the amount of items that are in the array, I don't know how to do the permutation. I'm honestly stumped. I know I would possibly, if I do this right, I probably have like an array that will store um, all the different permutations, but not in an array. I will actually store them as just strings. So instead of having like an array with one, two, three, I just have one, two, three as a string, in the array and one, three, two in the array. Um, and then I would try to um, sort them. Maybe even I'll do it like this. I probably turn them, I would store them in the array as actually a number as opposed to a string. And I'll store them all as numbers. And then with the original permutation of one, two, three, or whatever case, whatever the number is, I will also store this as a number. And then I will look up this array and try to find the key of where it's located, check whether or not if it's the last key of the array, or there's, and if it's not, good, then I will just go to the next key. But if it is, then I go to the first key because I will also have to like sort them. And I don't know if there's a sorting. It's just a permutation thing that's like killing me right now. So I already know I need to do the permutation, but the process to do it very fast is I'm not entirely sure of how I would go about doing that. Um, that's the thing that's like the hardest part. I think if I figured that part out, everything else seems like it would be easier. It feels like I gotta loop it, but there's all other things I might have to do. Mm, because there's 100 characters. How would I be able to rearrange all these characters or numbers and then check if the array even has this character match? Mm, I would not know how to do this. It's easy to do with one, two, three, but since it could also be 100 different characters or 100 different items within it, it's like, how would you be able to manage that and do it really quickly? Mm, 15 minutes have passed. Maybe I'll give myself 5 more minutes to really think about this. Mm, let me think here. Huh. How would you do that? I wouldn't know how to rearrange this. Let me see something. One, two, three, four, five, six, seven. Mm, mm, um, hmm, okay. I've been thinking about this and I honestly don't know. I think I'm just going to be staring at this for a very long time. So I'm going to ask Gemini, how do you figure this out? Yeah, let me get a tip. Instead of an explanation, let me get a tip for this. Finding the kth, okay. Generating all the permutations or finding the kth permutation are classic interview favorites. They often look daunting because of the factorial of O in, I don't know, exclamation point of generating them, but they follow highly structured mathematical rules, mastered in the next permutation algorithm lexicographical order. If you can memorize one algorithm for permutations, make it this one. It runs in O of n time and O of 1 space. The intuition relies on finding the pivot breakpoint where the increasing order from the right breaks. The three-step recipe, find the decreasing element breakpoint, scan the array from right to left. Find the I index such that nums I is less than nums I plus 1. If no such index exists, the array is entirely descending like 3 to 1. The permutation is absolutely the largest. Simply to reverse the entire array to get the smallest permutation, 1 to 3, find the successor, scan from right to left again to find a nums j that is strictly greater than nums I, swap nums I and j, reverse the suffix. Dealing with duplicates, backtracking the blueprint. Bro, just give me the what is the I honestly don't know. So it's telling I'm at least getting the impression. They say it's O of N. It seems like there's going to be two two loops. When the problem asks you to generate permutation of containing duplicate elements, a naive backtracking approach will generate the duplicate first. Always sort always sort the input array at the very beginning. This group duplicates elements together. Skip duplicates and backtracking if you're using a recursion loop. Skip the element if it is identical to the previous one and the previous element hasn't been used yet and the current recursion path. For generating all permutations of unique elements, you have two primary backtracking approaches. Approach A, swapping in place low memory. Great when you start to minimize space complexity as it modifies the array in place. For each position start in the array, swap the element at start with every element after it. Okay, it's been over 20 minutes. Just give me the answer. Can you solve the answer for this? Can you show me the answer to the next permutation? Okay, let me see here. All right, so you're counting the number, and if it's one or less than, you just return it to nothing. Um, then you do step one, find a decreasing element, the breakpoint from the right. So I was thinking of doing like a small loop, but it's doing n minus two. So if it's n minus two of I, n minus two of I. So is this supposed to be, why would be n minus two of I? And then it says if I is greater than or equal to zero and nums of I is greater than or equal to nums of I plus one minus I. Find the decreasing element. Breakpoint from the right. If a breakpoint was found. If I is greater than or equal to zero, step two, find the smallest element larger than nums I from the right. Which is n minus I. Hmm. I would never have figured this out. I would never have thought about this. Wow, nums j is less than or equal to nums I, j minus minus, and then you swap them. And in the swap, you have a temporary value. Huh, 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 huh. First element's the right of the breakpoint. So I and j find the smallest element nums I from the right. And so interesting is they always say that there are certain patterns that you shouldn't memorize the code or memorize the problem. You should memorize the patterns. I have never seen this pattern ever. I have never seen this pattern ever. And all the little questions or data structure and algorithm questions that are related to two pointers, I have never seen anyone talk about breakpoints or finding the decreasing element of a breakpoint. Like, so how would I even memorize this pattern? The swapping thing, this is a pattern I recognize. Let's start in this swap. Um, start and end, start plus plus end minus minus. Let me read this again. Yeah, I would never even got into this level. I'll probably get to this and just stop right here because everything else they're talking about breakpoints and all this other type of stuff. Master the next permutation algorithm, lexicographical order. The intuition relies on finding the pivot breakpoint where the increasing order from the right breaks. increasing order from the right breaks. So that basically means you can't find the next one. Like you're at the last one, I guess. Finding the decreasing element, the breakpoint, the decreasing element. Scan the array from left to right. Find the index. Find index I. If no such index exists, the array is highly descending like 321. The permutation is the absolute largest. Simply reverse the entire array to get to the smallest uh, permutation. I get this part. Find the successor. Scan from right to left again to find the first elements, nums j, that's strictly greater than nums I. Swap nums I and j. Scan from right to left. Reverse the suffix. Reverse all elements to the right of index I. Man, I'm going to ask tons of stupid questions. So, so the breakpoint is the last, is the highest, oops, permutation order? No, it is actually quite the opposite, but you're very close to right intuition. The suffix to the right of the breakpoint, that is the highest strictly descending permutation order. Here is the best way to visualize the suffix right to the of the breakpoint. This part of the array is sorted in descending order, 541, because it is descending. It's already at its absolute highest possible arrangement. You cannot make this specific subsection any larger. The breakpoint itself is the first number of the left of the highest order that is smaller than the element to its right. E.g., the 1 in 2, 1, 4, 2, 1, 5, 4, 3. Because the suffix is maxed out, the only way to get a larger overall permutation is step one index to the left, the breakpoint, and increase the number slightly by swapping it with the next best candidate from the suffix. Reversing the suffix afterwards resets from the highest descending order back to the lowest ascending order, completing the transition to the very next lexicographical step. That did not help me. That did not help me. Um, because this one is 541. Now it has like four digits. It has 21543, and like, wait, I'm sorry. It actually has five. It has five. I'm sorry. Um, two, 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 two. So let's trace this with the array. I didn't even read this part. How it works. Find the breakpoint. Scan from right to left. Is 3 less than 4? Keep going left. Is 4 less than 5? Keep going left. Is 5 greater than 1? Stop. Index I is 1. Value 1 is our breakpoint because it's smaller than the element to its right. Okay, let me keep reading. So it swaps it. This is doing the swapping. So if it's less than this number, it gets rearranged. Find the successor and swap. We scan from the right to the left to find the first number strictly greater than our breakpoint value, 1. Is 3 greater than 1? Stop. We swap the characters at these two positions. Reverse the suffix. We reverse everything after index I from index 2 so to 5 to the end of the array, which is 541. Gives us 145. So it's 23145. I see. So the breakpoint is the integer. I'm over 30 minutes. Anyways, yeah, this is confusing. Man, these data structures and algorithm questions are very hard, but I got to keep doing them until I finally figure it out. In any case, I'm going to end it right here.